What's going on, guys? We are going to do quadratic functions in real world or real life situations. This happens to be my all-time favorite quadratics lesson, so I'm really excited to get to this point. The reason I love this lesson so much is it kind of ties in everything we've done between units 14 and 15 now. It kind of brings it all together and applies it to some real world situations. So really cool stuff. I'm excited to get into it. So let's go through the do now. The do now says, consider the quadratic function shown below. What is the range of the function? Now, range involves the y values, right? So remember, quadratics, if this is a quadratic, it's going to hit a max or a min. And if we look at the outputs, 3, 9, 11, 9, 3, what we notice is this must be the vertex. That must be where the parabola turns. So we're going to have a maximum point at 11. So y has to be less than or equal to 11. Awesome. Hope that makes sense. Hey, we got a good video for you. If you want to copy and paste this link into your web browser and go watch that video, and then we will certainly fill these in together. So go ahead and pause this video, come back to this video in a few minutes, go watch this video. Really great video on things like maximum height and hitting the ground and all these kind of things, and then we'll have a better conversation. All right, so hopefully you got a chance to watch that video. All right, if the question asks, when does an object reach its maximum height? When we want the maximum height, we are going to look for the vertex. How do we find the vertex? Well, we're going to take our vertex formula. Well, this is the axis of symmetry formula. X equals negative b over 2a. This always gives us the x value of where this thing turns. Now, in real world, a lot of these parabolas are upside down. So they kind of go up, they hit a max, and they come back down, right? So that is what we are looking for, is this location, this highest point. And that's going to be the vertex, right? Now, when it says when, that's going to be the x value of our vertex. If it says what is the maximum height, that also has to do with the vertex, but instead of our x value, that is our y value. That is the output of how high it actually gets. And all we're going to do is take what we get from here and then substitute that value into the equation. Another thing you could also do is you could go to your table of values and find the XY pair that goes with this. And then you will know the vertex in total. Another common question is, how long is an object in the air? Well, if it's in the air, then it's not on the ground, right? So think about this. When does the object hit the ground? Well, these types of questions are involving the roots. Because what is the height, or what's the output when we have roots, or when we have zeros, or when we have x-intercepts? What is the output? The output is 0. Or in other words, the height is 0, so that must be on the ground. So whenever we see questions like this, we are going to try to find the roots. Now, how do we do that? We set y to 0 and then solve for x. You might say, how do I solve for x? Well, that's very easy. Go back to unit 14, where we told you how to solve quadratics. You could do square root functions. You can do square root method, excuse me. You could do factoring. You can use complete the square. You might see us today use the quadratic formula if it doesn't factor. A lot of times in real world, they're not always as nice looking, so sometimes we have to deal with that. All right, last question is, what is the initial height? Well, the initial height is going to be the y value where it starts. So that's going to be my y-intercept. All right, there are a few ways to get your y-intercept. You could set x equal to 0 and solve. Or if it's in standard form, just look at the c value. So the c value always tells you the y-intercept when it's in standard form. All right, let's get into this. We are going to do 3 problems. You might say, oh, great, only 3. Well, these 3 problems are involved. They might take us a little while, so hang in there. We're going to get through this lesson together. It's going to be awesome. Here we go. Number 1, a baking soda rocket is fired upwards with an initial speed of 80 feet per second. Its height above the ground, h, in feet, can be modeled using the equation h of t equals negative 16t squared plus 80t, where t is the time in seconds since the launch. All right. First off, why is this a negative leading coefficient? Because it's a rocket being fired upwards. So if you just think of this as kind of going up, it's going to hit some maximum, and then everyone knows gravity will then eventually pull something back down, 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 down. So that's why this is upside down, this parabola. It's shot upwards, okay? They're giving us a function that models the path where h of t is what? That's how high it is in terms of t, which is how long it's been in the air. So t is in seconds, h is the height in feet. Now, let's read the question. At what time does the rocket hit the ground? That's a key phrase right there, hit the ground. If it's hitting the ground, guess what we want? We want to find the roots, because the roots are where they cross the x-axis. The x-axis is the ground. Why is the x-axis the ground? Because y, which is our height, or h of t in this case, is going to be 0. What's the height at the ground? 0. So we want to make h of t equal to 0. We want the height to be 0. We want the height to be 0 because that's when it hits the ground. So we have negative 16t squared plus 80t equals 0. All right. One strategy that I really like here is I always see if everything divides by negative 16. And it does. So this can be simplified to t squared minus 5t equals 0. Everything divides by negative 16. Even 0, remember, 0 divides by negative 16. I love that. 0 divided by anything stays 0. Change the signs because you're dividing by a negative. Now, we're left with this nice, easy quadratic. How would I solve this? Well, this is not a square root method, right? We could use the quadratic formula, but this one factors really nicely. So why don't we go through and factor this? We're going to take out the GCF of t, and we are going to set each part to 0. So if I set each part to 0, I get t equals 0, and t minus 5 equals 0, which gives me t equals 5. Okay. Which one am I looking for? What time does the rocket hit the ground after being launched? So the time is 0. So basically what this says is before it was launched, where was the rocket? At the ground, right? So one of our answers is 0. So after 0 seconds is at the ground because it wasn't launched yet. But this is the one that I'm really interested in. This is the other value of t where it's also at the ground. So think of t as 0 here, but also think of t as 5 here. So it's in the air for a total of how long? 5 seconds from ground to ground. So at what time does it hit the ground? we're going to say 5 seconds is when this hits the ground. All right, go ahead and turn the page. We are going to do our second example here. All right, our second example is a baseball that's been hit into the outfield. Now, this baseball is also going to kind of go up, go up, go up, go up, and kind of come down, come down, come down, come down. It's going to be upside down, which means our leading coefficient, again, is going to be negative. Let me just get up a little bit so you can see it. Okay, so this is a negative leading coefficient, and it models the path of a ball. If a ball is hit, it goes up, and then it comes down, right? Okay, now, why is the y-intercept 3? Well, because think of a baseball player. They don't hit it off the ground. They hit it from a certain height. And if the bat swings through, it could be about 3 feet high where he first hits the ball. So here we go. Let's read this together. H is the height of the ball. Now, x is the horizontal distance the ball travels. So this is the horizontal distance, and h is the height. All right, we want to know the maximum height of this ball. So what are we looking for? We need to find the vertex, or the maximum point. How do I find the vertex? All right, so we're going to go and use our x equals negative b over 2a. So let's start filling in these values from here. So I have x equals negative 1 over 2 times a. Now, a is a nasty decimal, but that is okay because we're going to just plug this right into our calculator, and we're going to get a nice value of 100. All right, so what does that mean? It's traveling, and then after 100, are we in seconds, I believe? No, x is 100, the horizontal distance in feet. I guess it's in feet. It doesn't really say. H is the height, and x is the horizontal distance. So we're going to assume that's just in feet. That makes the most sense. All right, so after 100 feet of horizontal change, it is at its maximum height. But they want the maximum height, so 100 is not the maximum height. We got to find the y value that goes with our vertex. We want to know how high this thing has reached. So we are going to do one of two things. You can substitute 100 in here, so you would have negative 0.005 times 100 squared plus 100 plus 3. I can substitute 100 in, or I can go to my table of values. I can plug this into my calculator, go to where x is 100, and then I can find the output that goes with that, and you will get h equals 53. So what does that mean? It means the vertex is 100, 53. So after it travels 100 horizontal feet, it is 53 feet high. So what is the maximum height? Our answer is 53 feet. All right. An outfielder catches the ball 3 feet above the ground. How far has the ball traveled horizontally? Horizontally. So that's going to be an x value, right? So that's our horizontal